Now we just want to recap some basic finance formulas that we know, which we're going to need to use to combine the idea with arithmetic and geometric series. So the first one is just that simple interest idea. It's a very basic formula, PRT. I is the simple interest, P the principal, R is our interest rate, as a decimal or a fraction, it doesn't really matter, and T is our time periods. And it's a very simple formula because it's just assuming that the same rate of interest is applied, and in reality it doesn't happen like this, but $3,000 is invested for 7 years, simple interest. How much would it be worth after 7 years? I get in a PRT and we get 1,260, but make sure you read the question. It's saying how much would it be worth? We've just worked out the interest. So it's going to be worth 4,260 after 7 years. That's a very simple way of looking at interest, hence the name, simple interest. In reality, that doesn't happen because investment compounds over time. Compound interest then is this formula. And now we see the connection between arithmetic and geometric series, because if you look at it, when I write it in that form, it looks like the general term of a geometric series. Okay, the power's n instead of n minus 1, but that's no big deal. It still has that same form. Amount n, the amount after n time periods. P is our principal. R is now 1 plus the interest rate, because this formula does the compounding and works out the final amount, not the actual interest itself. And n, the number of time periods. Now, what we have to be careful with this one is that we match the compounding. So if they say per annum, then the time has to be in years. If they say quarterly, then time is in quarters, and the interest rate has to be in quarters. So $3,000 invested for 7 years, how much would it be worth if it's compounded annually? PR to the power of n, we get 3,000, 1.06 to the power of 7, and we get 4,510.89. But if we compound it monthly instead, now we change the interest rate, because interest rate's been quoted in per annum, and there'll be 84 time periods now instead of 7 years, and we get slightly more money by doing monthly compounding instead of yearly compounding. Depreciation is essentially exactly the same. There it is. Same formula. The difference is you're losing value, so instead of 1 plus, it's 1 minus. And again, you've got to match whatever that compounding time is, depreciation time. An espresso machine, it's absolutely amazing how much they cost, isn't it? Some people really love their coffee. $15,000, and that was in 2001, this example I got it from. So depreciates at 12.5% per annum. What will, very old question, because now I suppose I should say what was its value on the 1st of January 2010. Now there's our formula, substituting in, but now we're taking off the depreciation rate, and we get that, wow, it's now only worth $4,500. Now, during which year did the value drop below 10% its original cost? Well, its original cost was $15,000, so 10% is $1,500. We want to know when that is less than that. Exponential inequation to solve. Again, dividing by a log of a number smaller than 1, and we get greater than 17.24. So this time it's during the 18th year its value will drop. Okay.